Hello everyone, thank you for joining my session where I explain some reasons why as a JAKARTA EE developer you should switch to JDK 17. The title says 7, but actually there are even more reasons in this presentation, so you can make up your own 7 important reasons why you maybe should switch to JDK 17. As you know, the Duke has put on his T-shirt with 17 last September when the release of the platform came out, and so he's dreaming of making a sailing trip with the JAKARTA EE boat, with the JAKARTA EE8. But is that possible? Because at the time of JAKARTA EE8, there was, of course, no mention of JDK 17 at that point. And yes, it does work. I will show you a few examples, a few things that you need to know so that it works. But in case it would not work, then of course this would be a very short presentation. But you will see it is quite easily to get your JAKARTA EE8 application running on a runtime that supports also JDK 17. So I'm Rudy De Bussscher. I'm product manager for Payara and also developer advocate, so doing presentations like this one. And I'm also working in the microprofile and the JAKARTA EE specification, so I'm trying to build the future for those also. A quick look about what I'm talking about. We have language changes. We'll go over a few of them. How you can use them within JAKARTA EE, and I give a demo of how you can use that switch expressions, those text blocks and records. But I also discuss a few operational changes because there is more things changed in the JDK 17 than just some Java language construct. So also those operational changes can be an important factor to decide to switch to JDK 17. And as always, security comes at the end, which is, of course, not a good thing, especially now since we had the Log4 shell issue in December. But at the end, I try to sneak in one of those important things, which was changed for the security, also in the event from 11 to 17. So as you know, JDK 17 is currently the LTS version, long-term supported version. The next one will be in 2 years, not in 3 years. So in 2 years, JDK 21 will also be a LTS version. So LTS version means it's not replaced in 6 months. That also means that as a company, it is a good version to switch to because it gives you some stability. There are upgrades for the JVM each 3 months or so regarding bug fixes and security patches, etc. But from a language point of view, from a feature point of view, that means it is fixed, stable, and that's, of course, a nice thing to migrate to. Short update on JAKARTA EE. We have EE8, which I will use in the demo and talk today with the JavaX namespace. Officially, there is only a certification for runtimes when running on JDK 8. But as you will see, it also works on 11 and 17. We have the JAKARTA EE9 ones with the JAKARTA namespace, with that breaking namespace. And we have the upcoming EE10. It's expected in around 2 months. And that will include official certification for JDK 11 and 17. But you don't need to wait for JAKARTA EE10 to run on JDK 17, as you will see in this presentation and demo that I have prepared for you. The runtime needs to support it, of course, and for Payara, that means that as of November last year, with version 5.2021.9, we support 8, 11, and 17 as Java versions on JAKARTA EE8. So that's that's also the version that I'm going to use today. And other runtimes, that's not only PR, but also other runtimes support JDK 17. So there is a good chance that you can also switch to JDK 17. We all remember that the switch from JDK to 11 was a challenging one. That's also the reason that, or some for some companies, the reason why they are still running on Java 8. But the switch from JDK 11 to 17 is a much easier one, a much smaller one. There are a few things that are more encapsulated. So again, a few things are no longer accessible by default by your application, some packages, some classes. There are new things like records and some garbage collector changes and command line changes for some tools, as you will see. But overall, I believe that the majority of the users that are running today on JDK 11, that they will be switched by the end of the year to JDK 17 because there are only minor changes required. And JDK 17 has some important benefits. Benefits, as I mentioned, on the language features. The first few I'm going to discuss a bit more in detail. For sealed classes, for example, you can look up one of the tutorials that you find on the internet. And if you are trying to use something called Unix domain channels sockets, what, for instance, the Docker client is using to connect to the main runtime, then that's also now standardized. So that's now also easier to implement in JDK 17. Not only those language changes can be a reason, as I mentioned, also those operation changes have. There is a lot of work is done around the garbage collection and the performance. So you will see an example of that. You have, for instance, two new collectors with a very low pause time. So that means that they only stop the JVM execution for a very, very brief time. And for the rest, everything is done in concurrent with your application. They also work very well with very large heap size. So that's one thing that might be very interesting. We have that dynamic CDS archive. I'll show you an example of CDS archive is in one sentence because I can spend an entire presentation on CDS alone. You also have now flight recorder for monitoring purposes, not only for profiling and debugging purposes, which is nice. And you have support for that new CPU architecture. And then we have also a packaging tool now included. So in the case that when you're writing some client tools, some client applications that need to be installed on the machine of the user, then of course that packaging tool is very handy now for you. So let's go over a few of those language changes and see how you can use them or what you need to do in order to use them with the JAKARTA EE 8. This switch expression, it was a statement, so it did not return a value. Now you can have the situation where the switch itself returns a value. Can also be used easily with JAKARTA because it does not affect or influence the enterprise concepts that you are working with. So now with the arrow, you can indicate what the return value of that switch is, and that you, based on, for instance, here on the example that I also will show in the demo, based on the continent name, I return the Olympic color based on those one. You can use you can use the old style with the colon, just the case Asia colon there, as you see in the bottom. But then you need to use either break, which is confusing because break can also mean that you jump to a certain label, which is not the case here. And if you just want to put here a number like 1, 2, 3 or something, then the compiler will be very confused because a number cannot be a label. So don't use this break then anymore, but use the new keyword yield, which has nothing to do with the thread yield, but yield is another type of return, specifically for this switch expression. And that yield, you need to use it in any case, because that case element, as you saw in the previous slide, you can just return a constant, but you can also execute Java statements, call other methods and whatever. And after a few of those statements, then you have calculated your return value, and then in that case, you also need to use that yield keyword to return that value. Another nice addition for some scenarios, the new map multi method in streams. So you know that you have the filter and the map in streams already. You have filter to either decide if the element is kept or not, and map to convert it from one type to another type. But now map multi combines a bit those two and also adds a new possibility. With map multi, you can decide what value is handed over to the next step in your stream. So what is handed over downstream. So the map multi here takes lambdas with two parameters. The first one is your element in the stream itself. So suppose that this example is for a stream that contains some random numbers, for example. And the second one is then your downstream, represent your downstream steps. And then you can say, as you can see here, downstream.accept. So that means that you push a certain value downstream, which can be the same value which comes in, but it can be a converted one, or it can be a newly created one. In this case, there is a for loop. So in the case that the step here encounters the number 3, then you will have 3 elements in the downstream, which is 0, 1, and 2. So you created 3 elements out of 1 element. So that is a very useful tool, that this map multi one. And as mentioned, it has some elements from filter and map, and the ability to define what is going downstream and the number of elements that is going downstream. Another handy thing is the toList addition. Instead of saying collectors to list, you can just say toList, which is the same, but not exactly the same. I will show you in the demo that you should not start just replacing the second one, the old one, with the new one, because then you might end up with some errors in your program. So I'll show you the reason why in the demo. One of the major things which is in JDK 17, which is also discussed a lot the last few years, is the ability to have multi-line strings defined in your code, much more easier than before. And those text blocks. So now you can define those text blocks by specifying the text between between the triple quotes here. You have the beginning and the end, and everything between them is considered as text, including the new lines, etc. But of course, there was one thing that needs to be handled, and that was how are spaces handled, because some spaces are due to the fact that you are applying some kind of formatting to your text, to your code, and other spaces can be intentionally that they are part of the string that you want to end up in the variable unknown in this case. So this yellow line, so it's the location of the end triple quote, determines the difference between what's called incidental and intentional. Incidental is white space due to the formatting, so it's not considered as part of the string at the runtime. The spaces at the right are considered intentional, so they need to be part of the final string as it is generated your program. So be aware of where you place this end triple quote, because that can be important. Spaces at the end are always trimmed, so they are always removed unless you place somewhere behind at the end of what you think that is the end of the line a \s, and then you have the ability to include some spaces at the after the last word, after the last occurrence here of a character here, the n. You can add some additional spaces by using the \s. Second largely discussed feature is, of course, records. We all use data transfer objects, for instance, to define the structure of the JSON that we reply in JAKARTA EE. So records are now a very nice and easy way to get rid of all those getters and setters and all the boilerplate code. So your class code is now very compact. But there are two things which you need to know before you can use it within JAKARTA EE. One of them is that it is final, so a record is final. You cannot extend one record and create another record or a class based on that record, so that's not possible. But also the properties within the record are final, so that means that within the constructor, you always need to assign all the properties, in this case, the name and the continent name. And for those who have already seen it, I named the properties a bit special for records. I've used get name and get continent name, and not just name, for instance, because JSON-B specification, which converts between POJOs, Java POJOs, and JSON, only looks at the get matters. So get name is active for Boolean, for instance. But the records don't follow the Java Bean specification. So if I would have defined here only a parameter, a property name, a string name, then the getter, which would generate it automatically, would be with the signature string as return, name as the name of the method, and then just an empty parameter list. So it does not prepend get before the method that is generated. So if I would just use name here and continent name, then JSON-B would not see anything which is of any value for converting to JSON, and you would end up with an empty JSON object. So there are two options if you want to use a record with JSON binding. Either you create a custom writer, which means that for each record you need to define how that record in particular is converted to JSON and back. Or, as I did the trick here, you use the get name, so that the getter is also called get name, and of course JSON-B then finds the appropriate getter and is able to convert your record to JSON. You will see it also in the example. As I mentioned, constructors, there is if you write them, because it's not needed to write them, but if you write them to perform some additional checks or additional things, which is possible just like with any other constructor, you now have what's called a compact constructor, so you don't even specify the brackets. So it's just the name, no parameters, no bracket, just the name of the record. And then you have implicitly a constructor with two parameters at the same ones as on the record itself, so get name and get continent name. But as I mentioned, they are final. So that means that you need to assign them within your constructor. The classic constructor where you explicitly define the two, that's called the canonical one. And it's of course also possible to define a constructor with 3 parameters, with 1 parameter, etc., with 0 parameters, but then you have to explicitly use the brackets. So with constructors, there is a bit more diversity now with records than we knew before JDK 17. Something, again, not related to Jakarta EE at this time, but also a nice thing, because how many times do we write if O instance of country, and then within that if block we create a variable country and do a class casting. So to avoid the need to write that casting, the instance of test now can automatically assign your object when the instance of test is successfully, can assign it to a variable. So in this example, if O is indeed an instance of the class country, the variable country gets the reference also to the object, which is then a country, of course. After the successful execution of that test, then you can reference just as you can do with any kind of variable within a method. Following that flow scoping algorithm, you can use the variable name and then refer to the name property, for instance, in that class. Here, the if is inverted, so that means that on this line, our object is not a country, so we cannot use the country variable here within the if block, because at that point the test was false. But the point is, if it's successful, it is assigned and can be used from that point on. So in this case, it means after the test here. We have a similar thing for from what's also called pattern matching, but now for the switch, where we can, based on the object, if we say just switch of O, if it's a string, then we can assign it to the variable s and we can use it. If it's an integer, we can use it when it is assigned to the variable I, etc. So that's probably less useful than the instance of, but probably there are some cases where you can write this type of constructs in your application. And of course, the helpful null pointer exceptions. And now in a situation where you have a.b.c.d and you get a null pointer exception, you clearly get the message in the error saying p was NULL, and that's the reason why this failed. So no need to debug anymore or find out which one of those three are NULL, for instance. It's clearly indicated in the error message. So that's also useful, I guess, in many cases. So let us have a look at a demo and a few more tricks that you need to know before you can use your Jakarta EE application with JDK 17. So I'm using Jakarta EE Web API, that's still version 8. That's still, I think, used for in most cases, because not a lot of people have switched to 9. And the thing that we, of course, need to do is tell the compiler that we are writing source code with JDK 17 constructs and that it needs to compile to 17. And one thing that we need to do is change the version number of the Maven WAR plugin. Due to that stricter encapsulation, which I already mentioned from some internals, the older versions do not work on JDK 16 and higher. And that means by upgrading to the version 3.3.1, everything works fine on JDK 17. So, and your Maven WAR is created as you expect. So that's not the most difficult thing to do. I have here a JAKARTA endpoint, still my classic endpoint at path. I can inject CDI instances, not an issue. I can define JSON, I can define my URL, like countries, give me a list of all the countries in a certain continent. And as you could imagine, I'm returning a list of those DTOs where I already explained that you need to use either a writer, a custom writer, or this trick here to use get name and get continent name in order that it is properly recognized. The countries here, they come from, it could be a database. In this case, it's just a hard-coded in memory list. I can then stream and filter for the country that I need, and then I can map that one here with that new constructor with the canonical one, although I'm using the canonical one or the compact one, where I map the entity from the database. I map that to the data transfer object. I could have merged the filter and the map here with the multi-map, as explained. But I find it in this case more clear that I do a filter with a certain condition and then I do a conversion to that DTO. As I mentioned, you have that to list now instead of collectors to list. I can use it here, but be aware that this new to list returns an unmodifiable list. This older version with the collectors to list returns just an array list, so that can be modified. So in this case, it is just returned as JSON, so I don't need to change the content of it. But if you do change, then if you are using to list, then of course it will fail because an unmodifiable list does not allow to add or remove elements from your list. So don't blindly change every collectors to list here to a to list, because then you will have an issue. So let's see if I can get now my values. So Maven clean package. Show you I'm here running on a JDK 17 version. So I can do Maven clean package. My WAR file is created just as usual. There is nothing changed here, so WAR file is ready. I'm here also JDK 17. So that means that I can start up Payara Micro, and that's easy to start here, where I say that I don't need clustering because it is a simple program, and I'm referring to that WAR file which is created. And it starts up. You get again the information of the REST endpoints which are there. So that means that I can call curl to that endpoint. For instance, here, give me all the countries of Europe. And then you see that I get a JSON error back as expected. That list is converted to a JSON error with that continent name and that name property, which is derived from that get name and get continent name in the record. So that's working fine. Next example here is using those text blocks. I have here two variables defined with a text block. You see also that my IDE is helping me by drawing here a nice line. So these spaces here are intentional part of the result variable here. I'm using here that switch, what I explained, so returning the color based on the country. But this is just a string. I'm also helped here by my IDE. This is a standard string, so that means that I can just do string format. It is not because I'm using a text block that there is something specific on the variable. That's again just a string, which whatever I can do before. So I can replace here this placeholder with the values that I have put here in the method. And the end result here is that when I do a curl, I ask the Olympic color of country 56, which happens to be Belgium, where I'm living. And then you see here that those 3 or 4 spaces which are defined on the right of that line, so they are intentional, they are kept within the output here, represented by the output of this curl command. So from that point, from developer point of view, there are only a few things that you need to be aware of if you want to use something like a record with JAKARTA EE, and maybe here you have to change a version, but other than that, you can easily use the new JDK 17 language structures with JAKARTA EE 8 if the runtime supports it. But as mentioned, there are more things. One is the class data sharing, so that allows for a faster startup. You basically bypass the entire class loading and verification because you have done that upfront and have created an archive file which contains all the classes, all the data in your classes in an optimized format for the JVM. So that file can be mapped immediately into memory, which means you bypass basically the entire class loading, which for a larger applications and for runtimes like JAKARTA runtimes is of course a big benefit in starting up. In JDK 17, it was a 2-step process. At first, you had a list with all the classes that you need to generate. You could do it by hand, but that was a bit of a suicide mission, of course. If you create, you need to update a file with 10,000 entries. And that list can be created with that parameter xx_dump loaded class list. And Payara Micro had a specific parameter there for warm-up, saying that if everything is ready, if everything is loaded, then it shuts down the JVM again. And then due to this parameter, that means that the list was created. And then in the second step, you can create that dump file, here the payara.gsa file. And you had that file and you could start up your application, as you will see, much faster. Now in JDK 17 with the dynamic archive, that's it's much easier now. You have only one single command anymore, and one single step anymore that you need to do at the archive classes at exit. Because why first create a list with all the classes and then generate that archive file when actually all the information of the classes are available in memory, accessible by JVM when it is running, because they are loaded. So that idea came from OpenJ9, which already used this way of working in JDK 11, but when you have now that parameter archive classes at exit, if the JVM exits, the archive file is written based on the information within the memory, which is of course much easier, much faster. And again, this warm-up parameter is very handy to have it with Payara Micro. So I have Java 17 here. Double check to make sure it is the correct version. So let's see what benefit we can have from that CDS without rewriting your app application, and that's one of the major benefits of it. So this starts up Payara Micro specifically with that launcher, which can be used also for CDS, so that we can compare without CDS. So this is the normal one where I deploy an application, and again I ask for no clustering. So this is the startup what you do normally without any tricks available, and then you see it starts up here now around 5 seconds, which is more than a half second slower due to the screen sharing, because it is faster when I don't share the screen. Then I can create that archive file, so I can put the correct argument line here and archive classes at exit, and I use the same option which I would use otherwise. I put here a minus warm up now here, so that it stops automatically, so that I don't have to kill it with Control C. And then when the JVM exits, that archive file is written down. Not all the classes are can be written down, all the classes, and some of the classes which fail some verification, they are skipped. But you still can use them with the normal class loading. So that generates a file here about almost 73 megabyte, a bit smaller than the original Payara micro jar file. It's entirely read-only, so that no one can tamper with it. So it is safe to assume that all the information there is valid, that it not needs to be validated, etc. And then that means if you launch it now using that shared archive file which we created, and just specify the original class path for those classes which are not loaded, that's enough. We don't need to specify your application because that's already bundled in that archive file, etc. And then you see that instead of 5 seconds, it's now only 3.2 seconds, which is, of course, much faster. So some people find that important for a fast startup. So this is one option that you can do without the need to rewrite your application, and just to have that CDS archive file created and used during production, during runtime. In general terms, you can expect always a increase of the startup by around 35%, which is, of course, a nice one. But you can also have, in other ways, also a performance increase. I mentioned those two new garbage collectors, Shenandoah and ZGC, but also the G1 has improved between JDK 11 and 17. So I have the Payara micro binary, which is the same binary, actually compiled for JDK 8. So it's not optimized for 11, neither for 17. I have the same application, which is there, which one of the requests creates a lot of memory objects and high CPU. And I give it a very small heap size, 256 megabyte of heap size. And I executed it several times on JDK 11 and on 17. On average, the response time was 100% between all of them. But if you see, the average for JDK 11 was around 110%. For JDK 17, it was around 90%. So that means that there was a 20% faster execution of my code on JDK 17. And that's basically more or less to do with the improvements on the G1 compiler, on the G1 garbage collector. This is, of course, a very special situation. Your application will probably not be 20% faster due to that, because I'm creating a lot of memory objects with a small heap. But in general terms, your application, just by switching from 11 to 17, will be running much faster. There is also flight recorder now, which not only is for profiling, but for diagnostics also, where you can have, it's called event streaming. So flight recorder normally works by emitting each subsystem, like threading or compiler or whatever, emits some events. All those events are captured first in global in memory buffer, and then asynchronously dumped to disks, so that the performance is not impacted too much. You can expect something like 1 or 2% of impact by collecting these events. And when the JVM then exits, or when you ask for such a flight recorder dump file, then that file is assembled based on the fragments here in that repository. But now with that streaming, you can either, if you are doing it in the same process, your application itself can connect to this in-memory buffer and receive all the events which are coming. For instance, CPU usage, garbage collection events, or your own events. You can also capture your own events, of course. Or you can start up an external program which watches this repository, and you can get then the events from that repository as from inside a external application, a second application than the application which is generating the events. So how does that work? It's a bit work to set it up, but it's not that difficult. First of all, I'm starting a application, and I'm using the same application that I used for that testing of that that G1 garbage collector. So that's with not much memory, and the application. Then I need to configure the flight recorder, and that can be done outside. So I can externally connect to that process. First look up the process ID of that Payara Micro. Then I set that repository path so that I know it is at a fixed location and not in a temporary random location. And I start the recording, the flight recording. And then I can create a simple, plain old program in Java with the main class, where I connect to that repository, repository that I configured, and that event stream will then give me the events, for instance, the garbage collection events, which I print out. Starting up here will show nothing because my application, of course, here is idle. It is not doing anything. But if I launch that that endpoint, which generates a lot of memory objects and then triggers the garbage collection, you will see that there are events coming in my program. So I launch it. You see all those events in a second program outside of my main one. I see all the events coming along from every time there is a garbage collection going on. So this can be used for monitoring purposes, even tweaking your own program as it is running based on the feedback that it gets from the flight recorder. And as mentioned, the last thing, security. There are a lot of things. One of the most important things, which I just want to highlight in the last few minutes that I have, is that you have now what's called context-specific deserialization filters. You know that when you do Java serialization, that you have the possibility that some malicious content is in the serialized version, and that when you read it, that you get a issue, that you get a security issue, and that you have a problem. For instance, I create here what's called the gadgets chain. Not going into detail, but the idea is that when I read that serialized file back, it performs a listing of the current directory. Although I assume that it is a country DTO, so a list of data which is there, but it is of course hacked, and I have there some listing there. So when I'm running this program, you will see that of course fails, because there is here when I deserialize, I assume that it is a country DTO, which I'm reading back, but it is not. So that's why that's class cast exception. But you see, there is already the ls-l here is already performed. You have no way of blocking that. That's the way how that serialization worked before, and it is still working. It just reads in, and when you construct that gadget here properly, like here I do a command.run, then it executes the listing here. The safe way is that you can say that if a package name does not start with a certain in a certain package that you rejected, so you can already throw out a lot of garbage in your serialized files. You can do that globally with this object input filter, or you can do it locally here within your deserialization based on the input stream that you have here. You can set a filter there. If I try to run this safer program, again, I have here my ls-l. I run that. Due to all those filterings, then it says it is rejected. So my listing is not executed, so I'm safe now. And I get also an information that that someone tries to use a serialized content which is not it's not valid, so it's that tampered with. So this is a very important thing to fix one of the old the long-standing serialization issues in Java. So are there any questions? Let's see if there are any questions. So I give still some time to type in if someone has a question. So so the idea was that I showed you a few reasons. I showed you much more. If you will count all the things that I showed in JDK 17, that's around 14, but you can have around 7 of them. And I see here a question: why was the serialization filtering not fixed earlier? I don't know. They did a first attempt, I think, in JDK 13 with one of those filterings, but that was a bit an awkward solution. And then now I think it was in JDK 16 or something, they came up with this object input filtering. But I have no idea why they did not fix it earlier, because indeed it is already known since day one of the of Java. Anyone, another question?
I added another question about, is there a UI for looking through the event stream? You showed how you can print them with a simple program, but is there another way?
So for the event stream itself, there is no UI. There, of course, every event can be stored in that flight recorder file, and there you have a UI to analyze all the events. That's mostly used for the profiling and the diagnostics, not for monitoring. So the idea actually with that event stream is that it is for monitoring, so that it is continuous. so that you can react on it, so that it is programmatic. But if you want to have a UI for it, then you have to dump, you have to create the dump file itself, and then you have to open it in the flight recorder tools. That is a good question. I should have shown that you could also use that UI for a regular dump file to see what is going on. But then it's, of course, after the fact, not in real time. So I don't see any other questions. So thank you for joining me, and I hope you enjoy the rest of the sessions here at the Java 2 Days event.
Thank you, Rudy. I hope everybody starts using Java 17 after hearing your talk.
Okay, thanks. Bye.
Bye, everybody.